to take a few minutes this afternoon to walk through some of the models that we're going to be teaching in math over the next few weeks and give you an opportunity to interact with a few of these models so you will be able to help your students as we walk through these. And we know that standard algorithm is always an option when it comes to multiplying and dividing. We want our students to also be able to model some of these problems as well to truly show that they understand how the standard algorithm is really working. So spend some time with me today. I'm going to walk you through the multiplication and division problems specifically. And then if you've got any questions, don't hesitate to reach out and let your math teacher know. Let's get started. All right, as most of you know, if we were given a multiplication problem such as 45 times 31, many of you would go ahead and jump into standard algorithm and write this out, and then a lot of us were taught growing up to go ahead and multiply from that ones place. So this is 1 times 5 ones, and this is 1 times 4 tens. So that's why that 4 goes into the tens place. A lot of our students can't explain that to you though. They don't have that conceptual understanding of the place value. And then we move over to multiply by the tens place. And this is another place where a lot of times we've just taught our students to throw a 0 in or cross out that ones place and move over a place, sort of disregarding place value. So we really want to make sure they understand what's going on here. They are multiplying 3 tens times 5 ones here. So 3 tens times 5 ones, we're going to have that 5 is going to end up in our tens place here. So then 3 tens times 4 tens, that's actually saying 30 times 40. And then adding in one more 10, so that gives us 13 tens. So that's actually 1/1000 and then 3 hundredths. So this is kind of the old-fashioned or the standard algorithm that many of us learned growing up, and we've passed this on to our students. But we really want to focus on showing them how to model some of these problems. So we're building on that basis of place value. So as we do this, we're going to make sure that we understand that 45, if we use expanded form, is equivalent to 4 tens and 5 ones. And that 31 is equivalent to 3 tens and 1 1. And now we can go and we can actually multiply these using a grid format. And to build this grid, it's based on how many digits are in each number. So 45 has 2 digits. So I'm going to make a spot for 2 digits going this way. And I'm going to add 40 and 5. And then my 31 also has 2 digits. So going the opposite way here, I'm going to do a horizontal line. And now I have 2 digits going down the side here as well. So taking a look at this, you can see that I've now set up a situation where I can multiply my tens and my ones, and I can see exactly what's going on. So here, 30 times 40. Well, once again, most of your kids have learned this trick where they know that 3 times 4 is 12, and then they just count the zeros. That's a fine trick to know, but students need to make sure that they understand that this is 3 tens times 4 tens. And so they're coming up here with 12, but this is going to be, this one is now going to be in the thousands place after moving over. Okay. And then we're going to go to the next spot. And a good explanation is this is sort of like playing Battleship. So now we're going to take this 30 and we're going to multiply it by 5. So 3 tens times 5 is going to give me 150. All right, so now I'm going to move down to the next row here, and I have a 1 and a 40. So 1 times 40. And then for my last one here, I have 1 times 5. Now, when I get all of these partial products, which is what these are called, these are partial products, I now have to add those all together. Some students complain that this is a lot more time consuming than using the standard algorithm. And I don't think you're going to find anybody that's going to disagree with that. However, there are some students who will tell you that this is super helpful for them if they get stuck and they need some extra support. So we want to make sure that our kids have all of the strategies they could possibly need. So now we're going to add up these partial products. I just brought each of these over so I can add them. And my sum here, the sum of all these partial products, is equivalent to how I would have done it with standard algorithm. So this is just this is called an area model. So let's go ahead and look at one that's a little more complicated here. You can definitely try this with some problems on your own and compare standard algorithm with the area map, or the area model. So let's take one that's quite a bit more challenging here. So let's use 1,246 times 281. And let's first of all break this up into place values. So I can see here that 1,246. So there's a 1 in the thousands place, so that's 1,000. There's a 2 in the hundreds place, so 200. A 4 in the tens place, so 40. And then a 6 in the ones place, so that's 6. So if I add all of these back together, I do get the same numeral. Over here, I have a 2 in the hundreds place, an 8 in the tens place, and a 1 in the ones place. So to draw this particular area model, I see I have a 4-digit number times a 3-digit number. I could do this several different ways. I'm going to start by just drawing out. Sometimes I think for kids it's easier to go one row at a time. So here's one row of 4. There's another row of 4. And here's my last row of 4. So now I have a grid that's 4 by 3. And I'm going to put my numbers here. And using colors is always a great way to help students kind of get used to this strategy. Oh, I'm going off the screen there. Let's adjust a bit. Okay. Oops. All right. And then we'll go in and we will do our mathematical magic here. This is once again, we are combining everything we've learned with place value so far. Remember when we did all of those powers of tens and we multiplied by tens? This is a great place to practice that. So I have 200 times 1,000. So that gives me 200,000. And then I'm going to move over. I have 200 times 200. So that's going to give me 40,000. And now I have 200 times 40. And then I have 200 times 6. All right. And at this point, you can do this a couple of ways. And this is where your student has some choice. They can go ahead and add up one row at a time if that's comfortable for them. Or they can do all of the multiplication and then go back and work with the addition. So we'll try that to start with. Okay, so let's move on down. Here I've got 80 times 1,000. Then 80 times 200. 80 times 40. And 80 times 6. Okay, once again, you could stop and add all of your partials together or just wait and do that at the end all together. So down here, this one's pretty easy. I have 1 times 1,000, 1 times 200, 1 times 40, and 1 times 6. So you could add these. You could add by column or you could add by row. Completely up to you. Although I will say students need to be very careful as they're doing this and make sure they're keeping place values grouped together. So I'm going to go down here and I'm going to add across. I'm going to add in rows by color. All right, and just making certain that you are keeping up with those place values and keeping them nice and straight. All right, here's the next row. And once again, I know that some of you are already kind of laughing and chuckling to yourself and saying, I would never finish a problem if I had to do this for every single math problem. And that's true. That's absolutely true. And you're not going to find any of the math teachers here at GCA who are going to argue with that with you. We're giving you another tool to use so that if your student gets stuck or they need another option to solve, they have another tool in their backpack to use. All right, and then here's our last row. Okay, so now taking all of these partial products and adding these together, we're going to come up with 350,126. For the sake of time, I didn't rewrite all of that. But this is how you would do a larger area model. Once again, not always the most time-effective measure. However, if you're doing just a quick little problem, just something simple, and your student is stuck and they need some help, you could use this for something as simple as 42 times 5. Have them do a 2x1 grid. So this is 40 and 2, and then 5 here. And so they're multiplying. It's just like standard algorithm. So we're multiplying 5 times 40, which we know is going to be 200. And then they're multiplying 5 times 2. 5 ones times 2 ones. It's going to give us 10. And then we're going to add together and come out with 210. So this is just a wonderful strategy to reinforce that place value. So your student... All right, so we're also going to be working on division in this section and looking at some different division strategies that we can offer our students. Here in Georgia, our 5th grade standards do not include standard algorithm long division. But they do include using strategies to divide. So let's take a look at this. And let me show you how you can use an area model to divide very large numbers. So if I have 3,180 divided by 15, I'm going to come over here and I'm going to write this just like I was going to use that standard algorithm. But I'm going to think about friendly numbers here. What friendly numbers, what can I multiply by to get 15 close to something less than this number? Well, I could round this number and I know that that's 3,000. I know that 15 times 2 is 30. So if I add 2 more zeros on that, that's going to get me to 3,000. So this is actually here, I just did 15 times 200. And that got me 3,000. Well, I can represent that using an area model as well. I'm going to draw that over here. And I'm going to put 15 up here. And then I'm going to put 200 over here. So 200 times 15 is 3,000. Well, I still have some more to go over here. So when I do some subtraction here and take this away, I have 180 left. Well, 15 times what gets me close to 180 using friendly numbers? Well, I know that 15 times 10 is going to get me to 150. So 150, that was a friendly number. I'm going to bring that over here. And I'm going to add that on to my area model. I have 15, and I know that this was 10. So 15 times 10 is 150. All right, so now I'm going to go back and do some more subtracting here. I had 180, and I just figured out how to take out 150. That leaves me with 30. What can I multiply 15 by to get to 30? Well, that's a doubles fact, so I'm pretty familiar with that. So 15 times 2 gives me 30. So I'm going to add that on over here. So 15 times 2 is 30. All right, so I'm going to come over here and look at all of my partial pieces here. I see that I multiplied by 200. Then I multiplied by 10, and then I multiplied by 2. So when I add those together, I find out that the quotient, oops, I'm off the camera, sorry. The quotient to this problem of 3,180 divided by 15 is actually 212. I was able to figure that out without having to go through long division. So this is a great strategy, and it works well. And frankly, the area model part of it, you might not even use this part. You might just use this strategy here without keeping up with things in your area model. You could easily go back through to look and see what you had multiplied by and add those up. All right. So let's look at one last problem, because we know when we divide, things don't always come out evenly. So let's say that we have 1,438 divided by 13. All right, so I'm going to go ahead and write it over here with that as my divisor. All right. And I'm going to look and see what friendly numbers I can find here. How can I multiply to get from 13, to close to 1,400? Well, the best thing I know to do is multiply 13 times 100. So that's 13 times 100 gives me 1,300. Well, let me start my area model here. So I know that 13 times 100 is 1,300. Okay, and then I need to do some subtraction here. So when I take away 1,300, oops, that should be a 1. I end up with 138. Well, what fact could I use to get close to 138? Well, I could use 13 times 10. And that is going to get me to 130. So over here in my area model, I know that I just multiplied times 10, and I ended up with 130. So now when I go back and do my subtraction, because I still have something left over here, 138 minus 130, there's 8 left there. I cannot make a group of 13 from those 8 leftovers. So I'm just going to write down here 8 left over. This is your remainder. So when I go to write my quotient in, I'm going to look over here and I can see that I have 100 plus 10. So my quotient is going to be 110, and it's going to be remainder 8, or those, oops, I'm off the camera, sorry, are those 8 left over. So try using some of these strategies on your own. Parents, we know that standard algorithm exists. We know that students use standard algorithm, but we also want to reinforce using some of these strategies so students truly have an understanding of what we're doing when we are, we used to teach the cute little saying with divide, multiply, subtract, bring down. Well, the kids quickly just learned the system. They didn't learn exactly what that meant. So here they can see where they're taking out groups of 13. And that's what our goal is. We want the students to have a true understanding of what dividing really means, or what multiplication means. And that's why we're giving you these models to use. So we ask you to, yes, learn the model and be able to use the model and put it in your backpack. If you still go back and use standard algorithm, that's fine, but know what these models are. So if you have any questions about these models, and there will be some other models that are presented as we go through these units. I know that some folks have learned about the lattice method when you're using multiplication, and there's some other ones out there that have been used as well. But we're mainly going to be talking about the area models. So spend some time getting to know these models, and let us know if you have any questions. Thanks, guys. Have a good afternoon.